Alright, here we are, part 2, basic combinatorics, permutations and combinations. Start off by reading an example. If we have 51 contestants and we want to choose 10 finalists, how many possible ways can the 10 finalists be selected? Is this a permutation or a combination? In other words, does order matter or does it not matter? In this case, let's say we're just looking at 3 contestants, A, B, and C. If I was just choosing 3 of them, choosing A, B, and C would be the same as choosing B, C, and A, so no order doesn't matter. So let's take a look at our formula. A couple of things that I want to highlight. We're taking n objects chosen r at a time. We have the only thing different from the last formula is that we have another r factorial. We can't choose more objects than there are. And 0 factorial is equal to 1. And I'll provide a link that explains a little bit more about that. Quick note about the notation: it could be written either way. We could write it the way that you've seen more often in these PowerPoints, or we could write it stacked on top of each other. Either way, it's read and choose R. So just a quick note about the formula. We know this is the permutation formula, and we're basically dividing by R factorial again. Going back to taking the ABC example, let's say we had 10 objects and we're choosing 3. Or let's say the order doesn't matter. We would be doing 10 factorial over 7 factorial in the permutation, but we need to divide out the ones that are repetitions or redundant. So if we're looking at 3 objects, we've said that ABC is the same thing as BCA, and there are 3 factorial ways of arranging those 3 things. So we divide out the the number we've chosen, we'd have to divide by its factorial. So let's go ahead and set this up and solve it. We have 51 choose 10, which is equal to 51 factorial over 10 factorial times 41 factorial. So let's calculate that, which comes out to a really big number that we're going to use scientific notation for. Let's say we have 1.28 times 10 to the 10th ways of arranging. Alright, let's take a look at another one. Georgia lottery just requires winners to pick 6 numbers between 1 and 46, but the order doesn't matter. Keywords. How many different lottery tickets are possible? So we're looking at 46, choose 6. So try the next step on your own. Press pause. Hopefully you've set up something that looks like that. And then the evaluated answer. Here's another one. 6 seniors at Rydell High School meet the qualifications for a scholarship. The university allows the school to nominate up to 3 candidates, and the school always nominates at least 1. How many different choices could the nominating committee make? This one's a little bit more involved, so I want you to think about this one. We're going to answer this one tomorrow in class, so you might want to jot it down and maybe try and answer. It'll be your warm-up. The homework associated with this is going to be on these pages. You'll get those homework assignment sheets, and you can start keeping track of that.